So we could break this down a little bit more. XS is the rate of change of x with respect to x. So XS delta x is rate of change of x with respect to s multiplied by the delta s. That's the approximate change in x due to the change delta s. Okay, XS delta s. Now, why is this? It goes back to the definition of rate of change. And I'm not real happy with the way our curriculum fails to instill the whole concept of rate of change, because smart people come out of pre-calculus classes, which is where this is generally introduced and where it's supposed to be introduced in most curricula, and still don't know what a rate of change is. So they come to my physics or multivariable calculus class not understanding what a rate of change is, when rate of change is the most basic thing you have to understand calculus. So you don't know it from pre-calculus, and then you come out of calculus not knowing it because it was never really instilled. So we really need to understand this definition, okay? And this is multivariable calculus. It's high time everybody has a grasp of the idea, excuse me, of rate of change. The rate of change of x with respect to s, by definition of what we mean by rate of change of one variable with respect to another, is change in x divided by change in s. Now, there are more specific definitions. We don't have time and don't want to distract ourselves by going into the fuzzy details to make the definitions totally specific, but we should understand that a rate of change of x with respect to x is a change in x divided by a change in s. Now, this is an average rate of change, so we might want to use the word average. So if I multiply an average rate of change of x with respect to s by delta s, what do I get? Well, if I multiply this by delta s, I'll let you fill in the question mark and understand why I say that if you multiply the rate of change of x with respect to s, of course that's xs times delta s, and xs is the rate of change of x with respect to s, so that's the approximate change in the value of x. That's your approximate delta x there, due to the change delta s. So xs delta s is delta x. Now, within the context of what I'm saying here, because our x also changes when t changes, okay, I'll say due to delta x, okay? It's not the total delta x. Then fx is the rate of change of f with respect to x, and it follows from the same concept, the same definition, that fx times delta x would be fx ss delta x. And this is due to what delta s does just to x. So again, just due to the delta s. Now, delta s doesn't just change x, it changes y as well. Okay, so I didn't go in the direction I anticipated. Okay. Delta s also causes change in y, same argument. So you got an fy ys delta s here, just like you have an fx ss delta x here. I don't want to confuse the issue by going through every detail of that argument, but delta s causes y to change, and it's going to be by approximately ys delta s, since ys is the rate of change of y with respect to s. And that causes f to change by fy delta y, as it does, okay, approximately. And delta y being ys delta s, we get this. This means then that the total effect of delta s on f, and it affects it in two ways, right? If delta s changes, it changes x. I mean, if S changes by delta S. If there's a delta S, it changes X. And if there's a delta S, it changes Y. If you add those two changes, you get the approximate change in X. So the effect of delta S on F is the approximate, well, the total effect of delta S on F is the approximate change in F due to delta X. And that is just the sum of the Fx, Ss, Xs, delta X, delta S, you read it, tongue twister, and the Fy, Ys, delta S. Okay? Delta S causes X to change, and the change that you get is multiplied by Fx, because the change that you get is a change in X. Multiply that by Fx, your rate of change with respect to X, you get the change due to that delta S and its effect on X. And then you have delta S also having an effect on Y, and the change in Y multiplied by Fy, which is rate of change of F with respect to Y, gives you a change in F due to the effect of delta S on Y. And then similarly, if you've got a delta T, well, you multiply delta T by Xt, the rate of change of X with respect to T, and you get a change in X. And then you multiply, as always, that change in X by Fx to get the change in F due to the effect of delta T on X. But delta T also affects Y. So you multiply delta T by Yt, the rate of change of Y with respect to T, you get a change in Y. Multiplying the change in Y by Fy, you get another contribution to the change in F. And the total change in F is this plus this. So if S and T both change, what do you get? Your delta F is the sum of the change due to the delta S's as it affects S, X, and in turn the value of F. And as the delta S affects Y, causing a change in Y, which in turn causes a change through the Y partial derivative. And then you have the same thing for what delta T does. I'm not going to say it all for the delta T. And this is just the same expression we had over here. I'm just explaining it in a number of different ways. Okay, so then this could all be written in the partial derivative notation. I've been using the subscript notation for the partial derivatives just because it's more economical and maybe, I think, a little easier to look at when you're not used to it. But, you know, Fx is partial of F with respect to X. Xs is partial of X with respect to S. So we have partial of F with respect to X times partial of X with respect to S. And that kind of looks right because it looks like the partial X cancels. And then that's multiplied by delta S, since it's the delta S that causes this change in X. And then similar expression here, another one here, another one here, and you can think through exactly what they mean and how they relate to everything else. And you should think that through until you really have a pretty good understanding of this. And once you do, then it's pretty easy to see how the partial derivative will be written down for a function of any number of variables, each of which in turn is a function of any other number of variables. Now, if the number's too big, it's going to take forever to write it down, but you would understand how to do that, okay? Okay, well, there it is, and there's the basic meaning of these differentials and partial derivatives and the chain rule.